which are exactly encrypted by the message, or the message is encrypted in that, there is always an acknowledgement. What is that? Like if at all the received packet is correct or not, there will be acknowledgement from the receiver end, right? So anyway, that is total communication in that. But for your, oh, just a second, sorry, this Professor Rudra, just a second. Hey, I'm so sorry. You guys are logged in, right? Okay, now 84 people, right? But I cannot see your status. I don't know why. Hello, you guys are there?
Yes,
Yes,
ma'am.
ma'am.
Okay. So now our topic is, I want to detect a sequence means it is a, I can say it is a packet of bits, or what I should tell, like in fact, like group of bits. That's all. A sequence. Okay. So now we are trying to detect that sequence. I am calling it as SD, sequence detector, where the input will be provided bit by bit, and when the prescribed sequence is coming, then the output will be 1. Carefully understand. A prescribed sequence should be detected. That time it will show 1. So 1 means we got that sequence. Other than that, all the time it will be 0. In fact, this detector will be having again flip-flops only, right? But we are keeping in a block diagram, right? So as a mandate, I am keeping a clock also, so that it's an identification that you are using a group of flip-flops, in fact group of registers inside the block, right, who can work on a clock. Is that clear? Right. Now again I will tell you with an example. This X, which is nothing but a sequence, and say like I have it this. Some messages are coming, right? So now in that I have to detect 101. Carefully understand. So 101, so bit by bit, either from the LSB side or from the MSB side, one bit after one bit, it will go inside the block, right? Once this is coming, 101 comes, then output will be given 1. Otherwise, it will become 0. Are you understanding this? Is that clear? Because every step has to be very neatly understood. Otherwise, once the state machine starts, it becomes like an ocean. Are you understanding here? See,
Yes,
we
ma'am.
are set. Yes, we are having. These are group of messages. This is a random message of bits, or you consider it's a big chain of bits. In that, I have to detect only 101. Right? Only 101 I have to detect. That means bit by bit, let it go inside the detector. So whenever 101 is there, output will be showing high. In fact, I can show you the diagram. Like, for example, how it works. Let me tell you. If my data, okay, this is my startup. Right. So X 1, 0, 1. Okay. So let me consider this is the clock. Right. So my clock is the positive edge. Then in the second clock pulse, then a third clock pulse. Like that goes on. Okay, so let my clock pulse is like this. Right. Now hold on. I am showing some delay also. Why? Because exactly they cannot coincide. Right? Are you understanding this? A clock which is operating at a positive edge and trying to detect this 101. Okay, so how the output will be? All the time at this point it will be 0. Next point also it will be 0. Next point only after this one is detected, then it will go high. So all the time it will be at a low level. So this is what a simple representation of a sequence 101 getting detected from the group, like or from this system or from this machine. This is called system or machine. But be careful, inside machine we are not opening that. It's now a black box for us. First try to understand this particular input which goes bit by bit for every clock pulse. The output is just showing a acknowledgement. It will remain silent or it will remain 0 till the sequence is getting detected. You can extend this to detect for 1011 also. Like how? I can detect like this. Right? So that time output will not be like this. What will happen? Here also it will be like this. After one is detected, then only till that level. Did you understand how I have drawn? This one we don't know. It is afterwards. So these are the clock pulses. So after every clock pulse, it is checking the input coming. So once our prescribed at this point. Okay. Once our prescribed series comes, right? 1011. Okay. So I think you can adjust the scale. Please don't mind that. So 1011 comes, so it remains 1 only. Yours that remains that. Then after detection, it will give a high value. Is that fine? I have changed the number of bits also. 101 or 1011. This is what the job of a sequence detector. You have any doubt? Please interrupt me now. Once I enter into that, it will be difficult. Interrupt me now. Is that fine? Hello?
Is there no problem for delay?
Yes, ma'am.
Yes, ma'am. What happened?
Yes, ma'am, it's fine.
The delay.
No, somebody is asking something about delay.
Yes, ma'am. Is delay is not problem here anywhere.
Yes, now I'll tell you. So delay means what? It is since the information and we are using digital equipment, okay, which is again analog based also inside that. It is natural. It is natural. But every system is having a least count also. That means it can have a precision value that this much delay can be accepted. Why? Because if you see, that's why purposely I have written X input. It is also from a source. clock is from another source, we should have a synchronic mechanism. Will it really happen? Will it really happen? Just see, now itself, you people are telling something, I have to wait, concentrate, then listen, and then answer. Don't you think delay is there here also? It happens, right? But how much, we can say is acceptable, right? So tolerance levels also are there. So at present, for your design, we are not considering delay into consideration, right? Definitely delay is there. It's a research area, right? Hiranmay, did I answer your question?
Yes, ma'am.
Okay. So now this particular setup, which detects a sequence, detects a predetermined sequence, is nothing but a sequence detector, right? Now let me tell you an example. Another example, right? Now you will be getting some ideas if at all I am giving some examples. Now I have a message box, which is a sequence of bits, right? So it is something like this. Okay, now the message box or the messages are sent into the what I should say, into this sequence detector, and its job is to detect 110. Okay, the sequence detector is programmed. I can use the word program to detect 110. Right, carefully understand. So my sequence is 110 to be detected. Right, my output Z, in fact, I should use this one, has to have an option that shows 1 after detecting that. Right, so now no need of timing diagram, I can give here itself right now. Okay, so our target is 101, so I will say this is 101. So first bit enters, sequence detector has no say, so it will give output 0. Then afterwards, same thing with the second bit, same thing with the third bit. Third bit is very crucial. Why? Because my sequence detector has to detect 110, which is a 3 bit. Right. So similar here, first two itself are not following the sequence. Right, isn't it? So it's very obvious, since at the third bit also 010 is not our cup of tea, we can say. So ours is 110. Right. So now next one, same thing. Next one, same thing. What about here? It should be 1, isn't it? Just see. At this level, it is 0. At this level, it is 0. At this level, output will give 0. Next, this is next sequence started. Next sequence is started. At this one, and this one. At this point, the output is 1. Why? Because it has detected 110, which is our prescribed. Are you able to understand why that is showing 1?
Yes, ma'am.
Is that okay?
Yes,
right.
Like
yes, go. Like keep on going. So again the same thing. Here it is 0. Here it is 0. Here it will be 1. 110 sequence. Another sequence. Isn't it? Now just go. This is also 0. This is also 0. This is also 0. I'm not getting again 110 sequence. Isn't it?
Will be 1, second last one.
Second last one. Correct.
Will be 1, I think.
Yes, another one.
Why? This is 1. Here it is 0 only. Why, you know? Did I use? Now here the point comes. Now, is it an overlapping or a non-overlapping? If you see carefully, I am using a non-overlapping, isn't it? They are not overlapping. So I can say a sequence detector is broadly classified into 2. Who said it should be 1? Who is that? Can you just tell me your name?
Ma'am, Abhijit, ma'am.
Abhijit, yes. Abhijit,
Yes,
this is actually the classification. I didn't give you the classification. I just told it is just like this. Okay. Now actual classification I'm giving. A sequence detector is
Excuse me, ma'am.
basically non-overlapping and overlapping. Right? If you take up, I have given this example as a non-overlapping only I started. Because if you see, I have conditions here 3, 3, free. I didn't overlap at all. Did you check? Is that correct? So according to this, I don't think here it will be 1. It is basically a non-overlap. Isn't it? You will agree, Abhijit?
Yes, ma'am.
That's all. Good. So that is how we will enter into the second level, where we have whether the sequence detector is using a overlapping sequence or a non-overlapping sequence. Right? So hence we will again redefine this one in all the conditions. Okay. I will have to detect this, and by the way, I gave a very odd. Okay. 1 second. One more I will add because it is looking very odd. Okay, so that I can clearly tell that this is just example. I'm just giving as example. So this is an example of a non-overlapping sequence which will curtail or give a verdict after checking the last bit, third bit, every third bit. Now you see the circles. Clearly I am giving. This is a non-overlapping example, isn't it? Is that correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Now let us go with the same example as the overlapping, and for sure I will use only 1 bit overlapping. That means I can say, see, if at all this is done, first sequence is done, like first 3 is detected, I can use the last bit as the first bit to the next one. That is what called single bit overlapping. 1 bit overlapping. Let me tell you. This is, I'll write in green. Okay, so the same Z. Okay, for a single bit overlapping. Z for overlapping 1 bit. Clearly I mentioned only 1 bit overlapping is allowed because I'm the one who is deciding. Right. So how it will work? Now just see the first one. This is output. I'm not checking this. I'm talking about this one. Okay, check this first one. It is 0. Then 1. It is 0. This is 0, 1, 0. Why? Because my sequence is 1, 1, 0. Right. Now the next condition. This one is acting as the first bit to this. Overlap. Okay, that means my condition now, first bit is this one, first sequence is this, next sequence is this. Okay, next sequence is this. Are you able to understand? See, check the green dots. Next sequence is what? Now I am confused. This. Huh? Oh, sorry. Right? Isn't it? 1 bit overlap is allowed. Is that correct or not? Hello? You guys are there?
Yes, ma'am.
Yes, ma'am.
Yeah, clearly listen. Okay, so the first one, 0 star. Then afterwards, the next one is 1, 0, 1. Will be 0. Then afterwards, when this one comes, 0, 1, 1. Again 0. Then afterwards, when this comes, it is 1, 1, 0. I think it is 1 more. Is that fine? See, don't check this that. I'm checking this. If you want, best option is again write the X. That is good. Okay, best option is don't go with that. Allow 1 bit overlap. Okay, again I will write. So first sequence till here. Okay, so clearly this is this because my sequence is 1, 1, 0. Next one is this one is acting as this. So 0, 1, 1. No. Then afterwards, this particular one. At this point, it is looking at 1, 0, 0, 1, 1, 0. 1, 1, 0, it is 1 here. At this point, it is looking at 1, 0, 1. It is 0. At this point, it is looking at 0, 1, 1, which is 0. At this point, it is looking at 1. At this point, it is looking at 1, 0, 1, which is 0. At this point, it is looking at 0, 1, 1. It is 0. At this point what? 0. At this point, yes. Is 1 here? 1?
Yes, ma'am.
Yeah. Good. 18. Is that fine? Now see, I allow 1 bit overlap. Check your outputs. That and this that. Is there a difference? Yes, there is a difference at this point. 1 bit overlap. Is that clear? Please try to understand. Every time this is what I allowed. Every time this is what I allowed. 1 bit overlap. No questions? Easy? Is that detector is giving 2 different outputs? Yes or not? Oh God, what happened?
Yes, ma'am.
So sorry, why? Because outside it is very cloudy. For the last 3 days it is raining here. Okay, right? But anyway, are you able to understand or not? First tell that.
Yes, ma'am.
Right? Clear? Okay. So now, if I allow 2-bit overlap, okay, next level. If I allow 2-bit overlap, what will be my Z? Right? All my colors are over. So X again I will copy. Same thing I am repeating, and now again back to Z. Okay. Z with black. 2-bit overlap is allowed. That means the last 2 bits will be the first 2 bits of the next sequence. It is like this. Like that. 2 bits are allowed. Now can you just give me the Z value? Detect the same sequence 110. Yes. Hello guys. You guys are there?
At the fourth one, ma'am.
Yes, ma'am.
Yeah, please. Now give me the Z value. After finishing, then give me the Z value. I will tell. So I'll be writing for myself. Afterwards, you also just verify. Is that fine? Hello.
Yes, ma'am.
Right? That
Yes,
and
ma'am.
now let's check. For the same input sequence, because of our predetermined condition to detect 110 and the obligations what we have taken as a non-overlapping and a overlapping of 1 bit, overlapping of 2 bits, the output Z is different in each case. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yeah, this is what. So this is the preface of your sequence detector. Right now, to design such a machine, 2 people have proposed 2 different models. Right. So now it is up to you. Like you want to pick a non-overlapping, you can design. You can pick a 1-bit overlapping, you can design. 2-bit allowed. Right. So 3-bit overlapping is, I think it won't, because we are in fact detecting only a 3-bit sequence. Okay. So anyway, 2 people called Mine and Moore, or Moore they will tell you. These 2 fellows. these two have proposed state machines. Okay, they have given some modalities to how to design the state machines so that it can detect a particular sequence. It's not a generalized, a particular sequence, how it will detect. Is that fine? Did you understand now how to detect this? These two modalities I'll be explaining now. This fellow has proposed one, this fellow also has proposed one. Okay, so both the things we will understand, and then we will design in both the cases. We will see the pros and cons of every machine, then try to analyze or give a verdict which is better. Is that fine? Okay, should I rub it? You're understanding or not? Please give me a feedback.
Yes,
Otherwise,
ma'am.
this is very
Yes,
complicated
ma'am.
one. Okay. Now, first fellow, Mealy. Okay, what he told is he proposed a machine design, and he told that, okay, let first bit comes, right? Present input. We will call that technical word is present input comes, right? So it will decide what will be the next state to go. Okay, so that block will be there. Then afterwards, from the next state, it will go to a register. Okay, and then that register will again have, I mean, we will say that as a state register or a register, we will tell. Then that register will again consider as a present state, and then there will be a feedback to that. Like, let me tell you what will be there inside. Very easy. Don't get confused with your what these complicated words. So this is next calculate. I will tell next step calculator. Okay, just simply combinational circuit I will have inside. Combinational circuit. It takes an input which we will call present input. Present input. Right? Present input it will take, next state where it has to go, it will calculate. Then afterwards it will send it to a next state register. We will say next state register. Okay, so next state register will be having again a setup to state, because once it will go to next state means that becomes the present state to the next state. Okay, afterwards it will give an output. We will say output calculator. It is also a combinational circuit, and the final output will come. Don't get confused with this. I'll explain you very nicely with an example. Okay, so the present state again, right? And this particular one is again what I should say, it's combination of both. Clearly understand. See the arrows, right? Now, let me tell you with the sequence detector field. First, one bit will come, right? The decision making of that one bit, single bit only has entered into the machine. So it cannot decide anything because it is a minimum of 2-bit sequence it is detecting or 3-bit sequence it is detecting. So till that level, all the, for example, if 3 bits are detected, all the 3 bits has to enter so that a verdict will be given, isn't it? Bit by bit, if it enters, 3 bits has to come, otherwise it will not, isn't it? Yes or not?
Yes, ma'am.
Hello?
Yes, ma'am.
So this is what, till that level, the state register will be registering the bits only. Register, why I am saying? Because register has flip-flops. Flip-flops will store, no? Flip-flops will store. That's why I am using these words, fancy words. Right? This block actually is nothing but a storage. Right? So now, till that level, the present, the next, the present, next, like that it will go on. Then afterwards, the output, after taking care of all the 3 inputs. All the 3 inputs means what? First one has come, it is in the store register. Second one has come, it is in the register. The third one has come, then it enters into the register. Based on the third one only the output is decided, considering the previous 2 together. Did you understand? Is that correct?
Yes, ma'am.
So
Yes, ma'am.
that is how you see the output is definitely dependent on that level present input as well as your previous stored in the state register. register, whether they are next state or previous state doesn't matter. But the previous storage, including the present one who is coming. That's what I told now. The access coming up one bit after another bit. After this enters, taking care of this two, this becoming the present one, then only output is decided. Isn't it? Yes or not? Is that okay? Is that okay or not? Am I in the meeting?
Yes, ma'am.
Yeah.
Yes,
So this is what that Mealy fellow has proposed. Okay, I'll give you an example. Don't worry. That Mealy fellow has told check all the sequence, right? Whatever you are heading for. Then afterwards, the last bit, okay, for that particular predetermined sequence, which is serving as the present input, then only the output will be changed. Till that time, the sequence is not at all detected. That is what he told, Mealy. Right? Now, what Moore told is just the opposite. What he told, you just detect the sequence, that's all. Don't care about whether it is the present one or it's a previous one, nothing. You just keep on entertaining the sequence, right? Whenever you get, you just give. This is what Moore has done. Like verbally it is telling, it is a bit difficult to catch, but when we design it, it will be easy. Okay, little modalities are there, I'll explain you. Right, if you understand this, first we will take an example of Mealy, then I will go to Moore. Okay, so first thing is a Mealy machine. This circuit is a little complicated. Don't remember the circuit, I'll give you the example. So this particular circuit, what exactly it tells? It is trying to explain. Okay, it is trying to explain how exactly the sequence has to be detected. Take bit by bit, right? Then keep the output all the time low level only. Once the sequence is detected, you do the output, right? Based on that last input, which is acting as a present input to that. Okay, now let us consider an example. Right, so I'm erasing it. Let us consider an example of this. Actually, I'm meeting at 3:15, but I can finish it. Okay, now the sequence to be detected is 1101. Okay, now please write down step by step. If a sequence to be detected has n number of bits, okay, what Miller has proposed is it requires n states. Now, who is state, by the way? If you remember, I used the word state, no? One state to next state, another state to next state. You remember yesterday, we always use the word states. What do you mean by state? It is the condition, isn't it? Did we see in counters also PS and NS? Who are those?
It is a particular configuration of output.
That's what state. We will call it as state. Okay. So if at all you have n number of bits, according to the Mealy design, we will have n states. Right. So now here the sequence to be detected is 1101. Right. So n equal to what? 4. So when n equal to 4, the number of states required according to Mealy is 4 states required. Okay, and I don't know what are the states, so I will give some alphabets to that, A, B, C, D, E, something like that. Okay, so I have 4. That means I will use 4 states because state diagram is normally with the, you remember this, right? State diagrams. Isn't it? A, B, C, D. 4 states are required. I don't know the connection. Now I have to do the connections. That is what the logic is. How the state machine is going to detect. That's why the name starts with state. First the states has to be identified. Then the machine has to be designed. That means we have to complete this state diagram in order to detect this one. That is what the task is. Okay. Now hold on. First and foremost rule. Please try to understand. The connection of your states will always start from a starting state. Please try to understand. I have 4 states. Did you understand why I have 4 states? Because I have 4 bits to be detected. So by default, I will have 4 states. Is that statement fine?
Yes, ma'am.
Okay.
Yes, ma'am.
Right. So now ABCD is a variable of the state because I don't know what lies inside. So I'm giving by names ABCD. Right. Now A will be my starting state. Every time we always tell this starting as a start or idle or reset. These are all the words. So starting point is always a start state or an idle state or a reset state. See the names. Okay, so this is A serves like that, right? So from that point, we will try to move further and then try to connect. Why I will connect? Because I require to detect this particular sequence, right? Point number 1 is already over. We identified what is the start, right? Point number 2, the states will move further only when we have a bit which is helping for the detection of the sequence. Please try to understand. Every state in your state graph, when you are drawing, for every state we will have two ways. What are the two ways? If 0 comes, where it will go? If 1 comes, where it will go? Isn't it? I have two options. Is that correct?
Yes.
Remember that? You remember that or not?
Yes, ma'am.
Yes, ma'am.
So now always try to understand we have a forward movement only when I have a bit which is helping for the detection of the sequence. Now coming back to the example, I want a connection between A and B, right? So I can have a 0 as well as 1 connection also. But my sequence is what? It will start with 1. So I will only first identify that to move further only if 1 is there, right? And then I'm silent on 0. Okay, zeros I will take later. Why? Because my detection will be starting with 1, right? So the connectivity or the forward movement will be there if my bit is 1, because the predetermined sequence is 1, and first bit itself I don't get any output, so output remains 0. Is that correct? Is that fine? Is that fine or not? Is this
Yes, ma'am.
connection okay? Yes. Now hold on. Now where am I now? From the first state A or the idle state A, I have moved 1 step forward and reached B. Is that correct? Is that correct? So now my B I am keeping a count also, means like B is looking at 1. What is this box? This box means my position. That B state, I have reached B state because it has already crossed 1. It reached B after seeing 1. Can I use that word? After seeing 1, after getting 1, then only it reached B. Just see, it is good practice to note that. It's not necessary, but I am giving you very basic level. You will never get confused. Even if you see any records also or any videos or any textbooks also, this much explanation is not there. That's why I asked you specifically to follow my notes, my explanation bit by bit. If you are not getting, stop me that time itself. Okay, right? Don't hesitate. Okay, I am moving forward to B once 1 has come. So I already have a checkpoint. B has already seen 1. Right? Now from B to I should travel to C. Okay, so what I should do? What I should do? My sequence, like if I get 1 only, I am moving C because my sequence is 1, 1. Which is requirement I am first finishing. See, definitely there is a way of 0 also. Afterwards, I will fill it up. You are listening, right? Is that fine?
Yes, ma'am.
So now C has already seen 1, 1, isn't it? C has already seen 1, 1. I am at level C only after passing through A and B. Okay, but C is coming from B, right? So B is already 1 and C is also got 1. Then only I have reached C. Is that fine? This 1, 1 why I got at C? Because it has passed through stages, 2 stages. Is that fine?
Yes,
Okay.
ma'am.
Now, another. Now I should reach D. Now what should be my D forward movement? Is that a 0 or a 1? See, requirement is 0. Then I reach D. See the levels. I am moving forward as per my requirement. I am silent about the rest of the things. First, understand this glitch or this tactics. Okay, I am moving forward only in my required sequence mode. Okay, after D, what is the next choice? You require only one bit to complete the sequence detector, because 1101 is this is the example I have taken, isn't it? I require only one, isn't it?
Yes, ma'am.
Yes, all are sleeping. Everybody are sleeping,
Yes,
seems
ma'am.
to be. Okay, right. So now I will be silent about the last bit. Okay, because I have so many unfilled bits here. Okay, so what I am doing, I am holding it till this level because one more bit is required, and I will coming back again to the start point and try to address what are the other roots of this. Like, see, A has a forward movement if 1 is there. If 0 is there, what I should do? I have a doubt. If 0 comes starting, because you see, the sequence detector is designed for a particular sequence. It doesn't mean that any inputs, if it comes, it has to give a verdict, isn't it? So that's why I took the example of X and Y. So X and Z. X is a big sequence. Big sequence. In that, the real detector is on this. Okay, now hold on. If my A receives the starting bit as 0, what I should do? Think logically. If it is 0, yes,
Remain.
better stay back. Better is sit here only. Don't move at all. Because when there is a fruitful approach, then move. Okay, if there is no fruitful approach, because my sequence to be detected is not starting with 0. So hence stay back in that state. This is the wise decision. Okay, now please write that. Please write that. Okay, you make a point there. Right? Now, afterwards, it reached B. A is over now. A has two routes already decided. 1 means it is moving forward. 0 means it is staying back. Is that A chapter over? Is that
Yes,
over or
ma'am.
not? Right. Now, coming to B. So B got 1 already, like B, it reached B after receiving 1. Right. So now, if 1 comes, it is going forward. If 0 comes, what I should do? B. So that's
Go
what I
back to
do.
Y.
Yeah. See, this is the match. This one. If 1 comes, I have a route to go. Okay. This one is the same one I copied here. Okay. This one is the extra one. What B should do? If 0 it receives, isn't it? If
Go
1
back
it
to Y.
receives, it is moving. If 0 comes, what it should do? Now please try to understand. Match this with the one in the box. There is a mismatch. No? If there is a mismatch, please try to understand. Take this point. If there is a mismatch, simply go to the reset state. Please try to understand. This one is the decision making, because B is at a level 1. Okay, that one only I have copied outside the box. Right. If another one comes, it is moving. If 0 comes, what it should do, it doesn't move. Right. That time, decision is you better go back to the reset position and then keep an output 0. This is what decision making. Very clearly, we have to tactfully connect. Is that clear? Why B after receiving 0 has to reset? If 1 is there, it is moving forward. If 0 comes, it is, first thing is it is not there in the sequence. Second thing is there is a mismatch. Then reset it. Okay, so B level is done, right? So now we are in the level C. Now what is in the level C? Already 1 has seen. It is already seen 1, right? 0 means it is going further. 0 means it is moving 1. If another 1 comes, what it should do? What it should do if 1 comes? Here, how many
Go
bits
back
have
again
matched?
to
No. How many bits it has matched? How many bits? Here, first level, it is getting one more extra. Here, another one extra. That means matched with this two, with this two. There's a matching, no? See, here 1 bit match is done. Here 2-bit match has to be done. Outside the box to the inside the box. Is there a match? Matching is there. Yes. It is matched. 1 is matched with the box. So it's an indication you stay back if 1 comes giving output 0. Here mismatch is there. That's why go back. Here matching is there with the one which is inside the box, and who is inside the box? The C property is inside the box. That's why stay back in that same state. Did you understand there why I have to stay back? These are the rules I'm explaining here. So please try to copy. Okay. Connection, always remember. First thing is the box is the level of that, and next thing is the decision making. If 0 is coming, it is moving. Good. If 1 comes, what I should do? That is the question. If 1 comes, what I should do? This is the extra one. Right? So match 2 bits with the one in the box. Why I have to match 2 bits? Because in the box 2 bits are there. So I have to match 2 bits. Right? Is that fine? Now, hold on. We are in the last stage. Last stage is what? 1, 1, 0, 0. I have only 2 options. These 2 options. Because 1, 1, 0 already there. Either I will get 0 or 1. That's what is with D. Isn't it? Is that correct? Hello?
yes, ma'am.
Yes. Either 0 comes or 1 comes. Every time your sequence is done, you reset it. So if 0 comes, you reset it, giving an output 0. If 1 comes, you reset it, giving output 1. Finally, you got an output 1. Sequence is detected. Done and dusted. 1, 1, 0. After, if 0 comes, decision making, your output sequence is not there. If 1 comes, my output sequence is detected. Reset that, both the cases, then give an output 1. Very hard to believe. Okay, little confusing starting, but I think I did my best to explain, right, in every level. Please try to understand, point by point here. How I am making decisions at every level, where I should stop, where I should move further. So this is how, if you see now, all my states have the 2 ways completed. Is that fine? It takes a little bit time to understand. Okay, so now for you people, please, today's job is don't look into any state machines theory notes or any tube or videos or anything. You will get only confused. Right? Hold on till this level only. If you move further, again you will get a lot of confusion. I'm telling you, it's a what? Out of experience I'm telling you. Right? Never study ahead in the state machines, because everybody has a different logic to design, and you'll get lost. You will definitely get lost. Right? So follow, like I'm explaining afterwards. Once you master this one, you venture out into different aspects or different procedures. Is that fine? Now, in this one, anybody has doubts, please again ask me now itself, so that I can complete this and then stop the class. Quickly. Huh? Nobody has questions. Why?
Ma'am.
Yes, ma'am. Yes, ma'am.
What?
Ma'am, can you explain C?
Can we explain C? Okay. Can I explain C? Isn't it? Somebody is asking
Yes,
C, right? Okay.
Yes, ma'am. Yes,
Now,
ma'am.
yes, okay. Now the box, black box. This box has 2 digits. You understood why this 2 digits has come here?
Yes, ma'am.
No, C. The level C has already looked into 2 bits. Who are ahead to that? Who is ahead to that? There is a one forward movement only. Now, since it is completed, it will look very different. So earlier, only forward movement of 1 and 1 has come. Then I reached the 3rd state C. Okay, that's what I kept in the box. right? So the same one I am repeating here, right? So I have option of 1 1 taking a 0 and taking a 1. This is what happens. These are the two extra bits now I should think about, right? If 0 comes after C, it is going to D. That is already in the forward movement. Now if 1 comes, I should make a decision. That is what happens, isn't it? This is what a new topic, right? If 1 comes, what I should do? C has to stay where, or where it has to go. That is what the decision it has to take, right? So now, since in the box there are 2 bits ready, right? Your option or your way is to compare the extra bit along with its previous bit with the one in the box. If it matches, stay there. If it mismatches, reset it. Is that understood? Reset it. Now reset it means what? Where either to the or to the A state. That is afterwards we have to take decision. I didn't give an example. Okay. Example also, that also I will give you. Now here in this option there is a match. Then stay back. If there is a mismatch, you have 2 ways to go. Either you have to go to B or you have to go to A. Right? And when it has to go to B, because see, if this 2 is having a mismatch, then it will look into this, whether I will have to reach B level or not. If B is matching, then go there. 1 bit match it has to do, right? If this is also mismatch, then go to A. So that example I have not given you, but anyway, that I don't be uttering now. It will be getting confused. So this level C has to make a decision with the extra bit coming, whether to move, stay there or to move back. Okay. So luckily for this example, it is there. If we are unlucky, we have to take a decision back movement also. Right. That example I will continue tomorrow. This one is understood or not? Only that much you tell. This level.
Yes, ma'am. Understood.
This one, yeah.
Yes.
So this is
Yes.
yeah. This is, see, state machines are a little logic. Real digital and brains are understood here. Whether to stay there, move forward or move backward. This is how it has to plan, right? So I think it should be very clear. Now you can think of. Don't design anything. I won't be giving an example. Okay, this only 100 times in the word in different ways you can analyze. Okay, only this example you analyze. Don't take any other example. Right. This is what Mealy fellow has told. Right. Afterwards, who is A, B, C, D? We have to go further. Right. Till this level, I will stop now. Is that fine? Because actually there's a meeting. Is that okay?
Yes, ma'am.
Okay. Thank you. Thank you. So tomorrow class, if at all you are free anytime, just ping me. Shweta.
Yes, ma'am.
If tomorrow you are free, just tell me. Okay. Take care. Thank you.
Okay.